Hello. Hello, students.
Good morning, sir.
Good morning. Are you able to hear my voice?
Yes, sir.
Okay, right. Good morning, everyone.
Good morning, sir.
Good morning, sir.
Uh, Today, our welcome to our lecture on clustering. Today is the second day of our clustering lecture. So, before going to that one, let us recap what we have seen yesterday. Uh, Before going to this one, yesterday we couldn't find time for the question and answers of the yesterday's class. You people hold any kind of doubts from the yesterday's class, we can clear it in 2 to 3 minutes and we can move on to today's session. If anyone have any kind of doubts regarding the clustering, introduction to clustering and what are the different types of clustering techniques, what is the supervised and unsupervised learning, please feel free to ask any sort of questions if you have. So this is where we are going to start the class for today. Uh, Hoping that you have understood all the concepts of yesterday very well. I am taking today's class into account. So the main at the end of the session, you people as a student should be able to recap what we have studied yesterday and today. You have to understand what you mean by clustering and how we can cluster the objects into different groups, and at the end you need to understand what are the different clustering methods, what we are going to study about them in brief today, and if possible one or two clustering methods I am going to explain you in detail once we done with the brief explanation of the clustering techniques with a good set of examples what I am going to explain you for today. So basically the clustering is grouping of objects according to their similarity, grouping of objects according to their similarity. So either way we can define the clustering as grouping of objects according to dissimilarity also. Means the objects which are not similar, we are making them as a group. The objects which are similar, we are making them as a group. So certainly when we make them as a similar object as one group, certainly the dissimilar objects will be left out, which will form another group. So basing on this clustering, few methods are there. Clustering algorithms we are going to call them, because it is the first and foremost technique before applying any sort of data mining algorithms. The first method among it is a clustering algorithm such as a partitional clustering. So partitional clustering is dividing the data sets into different means of clusters, which we are going to call it as a k-means. K-means, in short, the k-means algorithm will fall under the category of the partitional clustering, means dividing the given group of data uh, into k-means of clusters, the k different clusters, and arranging them in a fashion where the group of similar objects will come into one group and the similar objects will come into another group. And there is a big process how we are going to implement this k-means clustering. because as you people are well aware of the iterative programming, so here the iteration will play a major role in this particular technique. And next, coming to the point of hierarchical clustering, the good example for this one is the adaptive hierarchical clustering, where arranging of the data or objects in the form of top-down and bottom-up approaches, basing whether you want to divide the cluster from the root node to the leaf node or from the leaf node to the root node, and we are going to have a good example even for that one. And next one is about the mixture of the Gaussians, where we are coming, will explain about the different model-based methods and the density-based methods which will come across, and let us have a good example even in this one also. Next, we have seen different clustering algorithms, but in these different clustering algorithms, one common thing is that a distance search similarity function is the common for all these algorithms, where we need to find the distance between the different objects which are available in the same cluster, and the distance between the objects which are present in the two dissimilar clusters. So, if you look into this point here, we are going to calculate the similarity distance by means of three different formulas. The one is the Euclidean distance we are going to find out, the Minkowski distance we are going to find out, and the cosine distance we are going to find out. And one more important thing is that you may implement any sort of clustering algorithm in order to make the data objects into different groups. But if the cluster is not of the qualitative one, if the clusters which are formed are of not qualitative, then there is no meaning in forming the clusters or applying any sort of algorithms to it. So to have a qualitative cluster, you people need to remember that is inter-cluster distance. The distance between the two different clusters need to be maximized. Means if you have the cluster C1, the cluster C2, and cluster C3, and in turn you have the different objects present in each and every cluster, but the distance between these clusters C1 and C2 should be maximized, and the distance between the C1, C3 should be maximized, and C2 and C3 should be maximized. And the other one is the intra-class distance, intra-clusters distance. In the sense, the objects present within the cluster. If you take only the C1 cluster, C1 as a cluster, the objects present in the cluster, the objects which are in the same cluster should have the very minimum distance, because we are saying the clustering is nothing but grouping of objects according to the same properties or likeliness, resemblance. Okay, so these objects should have similar qualities. That's why we are calling it as the intra-cluster distance. And at final, we have the quality of the clustering results depend on uh, the algorithm what we are applying, the distance function, and to which specific application we are making use of this particular algorithm. You see here we have the partitional clustering algorithms, hierarchical clustering, mixture of Gaussians, etc., etc. But here the important thing is that you see here the statement what I'm going to repeat, the quality of clustering result depends on the algorithm. So by using the partitional algorithm, we are going to get the qualitative cluster, or by using the hierarchical clustering, we are getting the qualitative cluster, or with the help of the mixture of the Gaussians, right? So by making use of any of the clustering algorithms, and as I have said, the distance or the similarity function is common for all algorithms to measure the distance between the objects, and to which specific application we are going to apply this particular algorithm. So this is about the different types of what we have here, the different clusters. Next, let us move on to the exclusive clustering, which is also going to be called as the hard clustering, where here the data point belongs exclusively to one cluster. You see, if you look into the two different clusters available here, where one cluster is represented in the form of blue color, the other cluster represented in the form of pink color, where the objects in blue So cluster are represented as the blue dots, and in the pink are represented as the pink dots. And the example for this one is the k-means clustering, where we don't have any sort of resemblance. You see, as we have gone through, if the cluster need to be very qualitative one, then uh, the interclass distance should be maximized. So if you look into these two clusters, we don't find any sort of resemblance among any sort of objects are existing in both of these clusters. Neither a pink dot is existing in the blue cluster, or blue dot is existing in the pink cluster. So we can say that here the data point or item belongs exclusively to one cluster, which is going to be called as the exclusive, means every cluster is exclusive of its own. And the good example for this one is the k-means clustering. Next, overlapping clustering, which is going to be called as soft cluster. Here the data point or item belongs to multiple clusters. So the example for this one is fuzzy or C-means clustering. So the data belonging to the objects belonging to the pink cluster, uh, the and the blue objects belonging to the blue cluster is going to be overlapped, and you could see this is the overlapping area of both of these clusters, right? So when these sort of when these sort of overlapping happens, so what sort of algorithm need to be applied in order to make them to form into a particular cluster, right? So this we are going to be called as a fuzzy clustering or C-means clustering, because in the fuzzy clustering, if you look into the term fuzzy in the sense we don't find the exact result, as we have seen with the k-means clustering, that if you want to have the result for that one, you'll get a result either in the form of a 0 or in the form of 1. Only the two things exist. But with the fuzzy, we don't find the exact result as 0 or 1, but we'll find the result in between 0 and 1. It might fall at 0 0.5, 0 0.3, 0 0.1, 0 0.7, anywhere. So the fuzzy results will be in the form of 0 to 1, not either on the 0 or on the 1, but in between 0 and 1, which we are going to call it as the fuzzy. This one we have already discussed. So major clustering approaches, which is nothing but the partitioning, construct various partitions and then evaluate them by some criteria. So uh, here in the partitioning, we are going to have some criteria. Basing on the criteria, we are going to do partitions, because how many partitions we need to do, we don't know. For this partitioning, we need to know the number of partitions to be done in advance, which is nothing but the criteria we are calling it as. So if you have criteria, then we can implement the partitioning clustering approach. Next, hierarchical. Create a hierarchical decomposition of the set of objects using some criteria. So here this hierarchy is going to be divided. Decomposition, you know the meaning of the decomposition. Either it might be dividing a big module into number of smaller modules, or adding the number of smaller modules to become a big module, right? So it means arranging in the form of a tree structure. Next, the model based one. Hypothesize a model for each cluster and find best fit of models to data. Next one is the density based method, means the number of objects existing in that particular area is nothing but the density based method. And a good example for this one, what we are going to talk about is the density of a population in a city in particular area, or the density of population in a particular state in a country, what we are going to talk. Next, the graph theoretic clustering. So the clustering can be well explained with the help of representing the given data sets in the form of graphs. So this is about the major clustering approaches. Now we are going to see about each clustering method in brief. So partitioning algorithm. So in the partitioning method, construct a partition of database D. So first we need to construct a partition of different databases. We need to have a database. As we have already studied, the database can be created with the help of transferring the data from the OLTP to OLAP process. So once the database is created, the database is going to consist of M objects in that one. We don't know how many objects the database is consisting of. That's why we are calling it as M objects. And we want to divide those M objects to form the different sort of clusters, which are nothing but the K cluster. So the data what is been available in this database is being divided into K clusters. So these M objects are going to be arranged in the form of K clusters. So given a K, find a partition of K clusters that optimizes the chosen partitioning criterion. So what do you mean by here given a K? So if you look into the previous slide, we have here uh, construct various partitions and then evaluate them by some criterion. So what do you mean by this sum criterion? This sum criterion is nothing but what we have here given a K. So into how many number of clusters the database can be divided having M objects in that particular database, right? So with this M objects, we are going to divide them into K clusters. Suppose if we have some uh, three clusters, K represents the three, suppose for an example. So it need to be divided into M objects. Suppose M objects are x1, x2, x3, x4, x5, x6, x7, and x till x9. Then K is going to be called as 3. Then K consists of K represents the three clusters. So C1, C2, C3 are the three clusters. Then C1 is going to consist of x1, x2, x3. C2 consists of x3, x4, x5, x6, and C3 consists of x7, x8, x9. So where these three clusters is going to consist of the data of M objects. So given a K, find a partition of K clusters that optimizes the chosen partitioning criterion. So global optimal exhaustively enumerate all partitions, and this is called as the heuristic method, which is called as the K-means, developed by the scientist called as the McQueen in the year 1967. So the K-means algorithm got discovered in the year 1967 by McQueen. So this is about the partitioning algorithm. Next, what we have is the hierarchical clustering, where you better know the meaning of hierarchy because we have studied about this hierarchy in various subjects. Hierarchy of storage devices, hierarchy in the trees, BFS, DFS, etc., etc. So let us take a small example of arranging the animal into different clusters, right? How it is being divided into. So animals are divided into two things, which are nothing but the vertebrates and invertebrates. The vertebrates are in turn divided into fish, reptile, amphibian, and mammal, and invertebrates are divided into worm, insects, and crustaceans. Okay, so you see here, if you look into this, vertebrates are divided into fish, where the fish can be in turn divided into anything what you can. It can be, the fish can be a kind of shark, or it can be kind of whale. In uh, the properties of the shark are different, the properties of the whales are different, even though both of them fall under the category of fish. If you're taking fish as a cluster, then in that cluster will come across all types of all types of living things which fall under the category of fish. But in turn, the fish can be divided into the shark and the whale, right? Depending on their herbivorous and carnivorous properties. Okay, and one more thing is that uh, uh, we can divide the cluster into till uh, the leaf node as much as possible, where the last object cannot be divided any further, right? Where the shark can be divided into further if there is a possibility, and the whale can be divided further if there is a possibility. If there is no possibility of dividing into further leaf nodes, then here uh, it stops. The process stops, and the implementation can be done. So produce a nested sequence of clusters. So we are calling it as, why we are calling it as nested sequence, because uh, each time uh, it can be divided into further, and it can be rebounds to get some data. Okay, next. One approach, recursive application of partitional clustering algorithm. So hierarchical clustering, we are going to call it as, we can call even it as a recursive application of partitional clustering algorithm. This is another thing. So in the similar way, the reptiles can be divided further, the amphibians can be divided, the mammals can be divided, and the worms, insects, etc., can be divided further to have the more insight into the hierarchical clustering, till the last point where the object cannot be divided anything further. Till that particular point, the clustering happens, and basing on the quality of the objects what have been existing, then they are going to be grouped together to form a cluster. So hope you have understood about the hierarchical clustering. And next I'm going to another example of the hierarchical clustering. So if you look into this one here, uh, if you look the first figure, we could have uh, six different objects, A, B, C, D, E, and F, where A and B are placed in one cluster, C is placed out, and E and D are placed in another cluster, and F is placed separately. So when we want to make these objects into to form a good cluster, then let us see the first step based on similarity. You see, combine A and B based on similarity, which is already been formed here. A and B are into one cluster, and combine D and E based on similarity. So as A and B have the similar properties, and E and D have similar properties, they have been combined to form the two clusters where the objects C and F are left out. And the next step in the process of forming the cluster, combination of A and B is combined with C. So A and B are combined with C, uh, where these three things have come into one cluster, A, B, and C now. But even though they have come under one cluster, in turn you see A and B is a separate cluster once again inside, whereas even though the C has here, this is one cluster. In this cluster, we have once again A and B as another cluster, because C has certain properties uh, where A and B are having, but not exactly matching. But that's why we have arranged in the form of a hierarchical fashion here, A and B at the same level where they have the common properties, and here you see the C, which is combined latter. Next, combination of D and E is combined with F, the similar way as done with A, B, and C. Here we have E and D, which is being combined with F. Next, the final tree contains all clusters combined into a single cluster. You see here. Now, earlier we had only two clusters here. Now, even after adding C into A and B, we got one cluster, and here another cluster we have, and here also after C combining with A and B, we have one cluster, and F combined with D and E, another cluster. Even though in turn we have AB as one cluster, and D and E as another cluster. Thereafter here, after a final tree contains all clusters combined into a single cluster. So this is one cluster and this is one cluster, which are combined together to form a big cluster here once again. So which is nothing but the hierarchy of clusters. So if you look, A, B are connected, B and E are connected, and A is combined, AB combined with C, and D combined with F, which, and thereafter A, B, C, D, and E and F. These two clusters forms a hierarchical clustering once again. The model-based clustering. So a model is a hypothesized example. Assume data is generated by a mixture of underlying probability distributions and fit the data to that particular model. So if you have a little understanding of the probability concept, the probability of occurrence of so and so thing, so where this object is going to fall, whether it is going to fall in the cluster of greens, the cluster of blues, or the cluster of reds. So depending on the probability density, the objects are going to be fit into that particular model, and we are going to discuss about this model-based clustering in detail in the coming class. Next, the density-based clustering. So based on density connected points, locates regions of high density uh, separated by regions of low density. Okay, so here, if you look into the figure where we have the dots of reds and blues, so the dots of reds and blues represents that the availability of more number of objects in that particular area. So basically, the meaning of the density is that the large number or huge number of objects existing in that particular region. So basing on that density, uh, here the clustering is measured. Just for an example, if you take the density of the population existing in the heart of the city when compared to the density of the population existing in external part of the city. So certainly will come across huge number of large number of people living in the central part of the city when compared to that of the exterior part of city. Means it also varies where the people will live depending on their requirement. So according to that, based on the density of the connected points, here the clustering is going to be calculated, and the best example for that one is the DB scan, which is nothing but the database scan, and we are going to study about this density-based clustering in detail in the coming class. And the next one is the graph theoretic clustering. So arranging the objects in the form of nodes and connecting connecting these nodes or the objects which we are going to call them as the weights. So uh, here the weights of edges between the items nodes based on similarity. So the nodes are being connected uh, basing on the similarity between the different objects, right? So if you look into one, the node one is connected to node two, it is connected to 3, 4, and it is connected to 8. So the node one is connected to these other nodes basing on the similarity. So the node one is similar to node two, and the node one is similar to node three, and it is similar to 4 and similar to 8. Just if you look into this one, uh, you can better understand this one with the help of the distance vector algorithm or the shortest path routing algorithm while calculating the distance between the nodes. So in the similar way, the similarity, we are going to implement a technique called as a similarity measure technique, where the distance between the two objects is calculated d of uh, x1 comma x2, where the distance, the similarity or dissimilarity between the two objects can be calculated by means of similarity measure formula, what we are going to see in the coming slides. So this is the dissimilarity measure. So distance metric or scale dependent. So Minkowski family of distance measure here d of xi comma xj, the distance between the object xi and xj is calculated by means of sigma s is equal to 1 to m, where it is divided into the number of clusters from S is equal to 1 to m clusters, xis minus xjs to the power of p whole to the power of 1 by p, where here p, if p is going to be 1, then it is going to be called as the Manhattan distance, and if p is equal to 2, it is going to be called as the Euclidean distance. Just by applying p is equal to 1 in the given formula, it will become the Manhattan distance, and if p is equal to 2, then it is going to become the Euclidean distance. Okay, so next, the cosine distance can be calculated as cosine of xi comma xj, where xi represents one sort of cluster and xj represents another sort. Then xi dot xj by mod of xi dot mod of xj is the formula for calculating the similarity or dissimilarity between the two different objects in the two different clusters, or the two different objects in the same cluster. So we can uh, don't think otherwise that you can calculate only the similarity between the two objects in the two different clusters, but you need to calculate the similarity between the two objects in the same cluster, how similar they are. Okay, so this is about the similarity measure and the correlation coefficient. So the earlier one is the scale dependent, and this is the scale invariant. So here the Mahalanobis distance, we are going to calculate it as d of xi comma xj as xi square root of xi minus xj sigma to the power of minus 1 of xi minus xj. And about this Mahalanobis distance and Pearson correlation, where we are going to use exactly, in which particular algorithms we are going to use, and I'm going to explain you about these similarity measures at that point of time in detail, because there is no meaning in explaining these things in advance. Okay, so next, this is the Pearson correlation, the formula given here. So once the clustering is being formed, then here we are going to evaluate the quality of the clustering based on the internal evaluation and external evaluation. So we have to do internal evaluation among the clustering and external evaluation. So internal evaluation is nothing but evaluating the objects within the same cluster, uh, similarity within a cluster and low similarity between the clusters. Okay, and the other one is finding external evaluation is nothing but finding the uh, similarity between two objects existing in the two different clusters. So this is how we can calculate the quality of the clustering. So the quality can be uh, calculated either within the same cluster or between the two different clusters also. Okay, so the quality, if the objects in the quality, objects in a similar in single cluster, uh, the distance between the two objects in the same cluster is minimum, then we can say that it is a qualitative cluster. And if this, the similarity between the two objects is more, then we can say this particular object should be moved on to another cluster, which is nothing but the inter-clustering distance. So let us see k-means clustering in detail. The k-means clustering is the one which will fall under the partitioning algorithms. So the k-means is a clustering algorithm whose main goal is to group similar elements or data points into a cluster. Note K in K-means represents the number of clusters. So, dear students, all of you blindly remember what do you mean by K in the K-means clustering. K in the K-means clustering is that you have a set of data, or you have a database which is been consisting of m different objects, and in by making use of this K-means clustering, uh, to how many clusters we can divide these m objects in the database D. So with the help of this k-means clustering, you need to know k in advance in order to implement this partitioning algorithm. That is the criteria of this one. Whether you have three number of clusters, k is equal to 3 represents whether we have three different clusters, and these three different clusters should be arranged with the help of m objects. M can be 10, So these 10 objects should be formed into 3 different clusters in the database B. So that's why uh, you kindly remember the definition of this one. K means is a clustering algorithm whose main goal is to group similar elements or data points into a cluster. So K means represents the number of clusters. Another example for this one is the document classifier, where the if you look into this one, at the center we have a quality control workshop, where at the left side you have the machine learning, and at the right you have the automatic classifier. So the books from this particular document classifier, the documents will be coming inside this into this fashion, and uh, automatic classification will be done. So here you have a machine learning. Machine learning is nothing but we are going to implement an algorithm. An algorithm is being applied, and that algorithm is responsible for arranging the data which comes into this particular set with the help of automatic classification. Automatic classification techniques will be applied on the incoming data with the help of uh, machine learning. Here it is mentioned as a machine learning. We can make use this one as a different data mining algorithm. Data mining algorithm, okay, or data science algorithms. It different because the advancement of the data mining is nothing but the machine learning. We can say machine learning, data science, artificial intelligence. Okay, so different algorithms will be applied here in order to automatically classify them, and this is the classification workflow, and the documents are going to be classified here at the bottom, and here it is we are going to control the quality control workshop. If the quality does not exist, then once again the repetition of the step will take place until the qualitative cluster forms, cluster of documents. So the step one of the k-means clustering. Step one, select the number of clusters to be identified. That is, select a value for k is equal to 3 in this case. So I have taken an example where here we have a set of data points which are arranged on a particular line, where we have we have some 12 different data points and data objects which are being available here, and we divided into 3 different clusters. So as I'm saying, the data points are divided into 3 different clusters. So k is going to become here 3, because it is the predetermined criterion for k means clustering. To how many clusters the data points need to be divided into. So that's why we have select the number of clusters to be identified. Next, select the number of clusters to be identified, that is select value k equal to 3, what we have already done. And next, randomly select uh, 3 distinct data points. So I want to randomly select from a given set of data points uh, 3 distinct data points, because I want to arrange these data points, the 12 data points, in the form of 3 different clusters. So how I can do that one? So I am randomly selecting 3 different data points. I can select the data points from this one, and this one. Don't uh, think that as I have created some space between these 2 data points and these 2 data points, that these 3 are already clustered, and these 4 are one cluster, these 4 are one cluster, and these 4 are another cluster. It is not at all right. I am just I have placed some data points on this particular line, and now I am going to randomly select 3 distinct data points from a given set of data points. So I have selected here this one as one data point, and the blue one as another data point. I am representing the green with another one where I have selected another data point. Next, So once I have selected three distinct data points, measure the distance between first point and selected three clusters. So I want to measure the distance between the first point and the selected three clusters. So this is the first point, what I am going to call it as. The first data point on a given line is the first data point, and measure the distance between the first point and selected three clusters. So this one, so the first data point to the data point what I have selected, right? Where I have selected this as the distinct data point. So I want marking this one with the red color, and from blue to the first data point, and from the third one what I have selected to this one. So distance from point 1 to the green color, distance from point 1 to the blue color, and distance from point 1 to the red color. This is what I mean to say here. So distance from point 1 to the red color, distance from point 1 to the blue color, and distance from point 1 to the green color. So these are the three steps what we have followed. First, select the number of clusters to be identified. So given a set of data points, and I have selected three as the cluster, three different, I want to make the data sets as three different clusters. And next, randomly I have selected three distinct data points, and I have measured the distance from the first, from the distance from point 1 to the respective data point, that is red, blue, and green color. Now the step is fourth one. Step 1, assign the first point to the nearest cluster. Assign the first point to the nearest cluster, red in this case. You see here, uh, assign the first point to the nearest cluster. So this is the first point, and the nearest one to this first point is red color. That's why I am assigning the red color in this case. So step 5, calculate the mean value according to the new point for the red cluster. So as the mean between the mean for this particular cluster, calculate the mean value including the new point. So this is the new point what we are going to call it as for the red cluster. So we are calling this as the red cluster because randomly we have selected. So I want to calculate the mean between these two particular values. So find to which cluster does point 2 belongs to, and how. Repeat the same procedure but measure the distance to the red mean. Now here, distance from point 2 to the red color, this is the mean value what I am going to calculate. The distance from this to this one. Next, find to which cluster does point 2 belongs to, and how. Repeat the same procedure but measure the distance in the red mean. Distance from point 2 to the blue. So this is one what we have measured in earlier. This measure we have taken distance from point 2 to the red cluster, and distance from point 2 to the blue one, and next comes distance from point 2 to the green color. So calculate the cluster mean including the new point. So here we are going to get the cluster mean. This is the new cluster mean including the new point. This is the new cluster mean what we have got here. And next, measure the distance. So how the distance is going to be measured. Assign the point to the nearest cluster. Calculate the cluster mean using the new point. So to which cluster does this point belongs to? So as we have done implemented this one, so this entire part has become one cluster because if you look into the figure, these points are arranged in the form of red color, and now here we need to calculate the distance measure for this one. Now now select this particular blue point, the point, and calculate the mean distance between, calculate the distance between these two things. You see here what is being mentioned, and from here to this, because uh, this one will fall under. These two are already moved to the cluster, and we are not going to touch them. Now we are going to calculate, because uh, in earlier steps we have calculated the distance from one to one, one to one, and now we are looking into this one. So we are going to calculate the distance from this particular point. So blue to the first point in this particular group. And next, to which cluster does this point belongs to? Now we need to find to which cluster this particular point belongs to, and we need to calculate the mean for that one, similarity distance. Next, since all of these points are located closest to green cluster, so all of them will be assigned to green. So don't think that simply that as we are arranging them in the form of colors, we are getting the data points are being moved to that particular cluster. It is totally depending on the mean by calculating the similarity measure, the mean value between different data points. So here the result from the first iteration, what we have got here is this one, but the original or the expected result is this. So until the given data points will come into the form of original or expected result, the data need to be moved, and it need to be arranged. And as we have said, the k-means clustering is a iterative one. So as after the completion of the first iteration step, this is the result, and once again we are going to implement the second iteration, where we are going to get the second set of results, and this need to be repeated until we'll get this original or expected result. So once the original or expected result comes out, the algorithm stops, and it gives the final result, where the given data being divided into three different clusters having the common objects. And so the total variance within the color. So according to the k-means algorithm, it iterates over again and again unless and until the data points within each cluster stops changing. So that is what. So here it keeps on changing the data point. The color of the data points keeps on changing until will achieve this particular result. That is what he means to say. So according to k-means algorithm, it iterates over again and again unless and until the data points within each cluster stops changing. So the data points should stop moving. So this is about the k-means clustering. So this is about the text, the algorithm, the same algorithm what we have seen with an example. The same thing is being repeated here once again in the form of textual points for your sake of your reading. And this is another example. So in a similar way, how the data points will move if you look into this one, the different data available here. This is the first another step by calculating the measure of this one. So step by step, step 2, step 3. So here the data is being aligned. So if we have not formed a good cluster, then once again it is going to be repeated, and which is nothing but the step 4, step 2 to step 3. This iteration takes place. It is the k-means clustering is an iterative algorithm. So the k-means clustering method relatively efficient, where n is the objects, k is the clusters, and p is the number of iterations. The weakness, the applicable only when means is defined. That is, we need to only when mean is to be defined in the vector space, and need to specify k the number of clusters in advance. So without knowing how many clusters the data points need to be divided, we cannot understand what does this k mean is. So it is sensitive to noisy data and outliers, since small number of such data can substantially influence the mean value. So there is a possibility of changing the mean value because of the noise or outliers. So this is one of the drawback of the k-means clustering algorithm. And thank you, students. Tomorrow I am going to come up with another algorithm called as the hierarchical clustering algorithm. So if you have any sort of doubts, kindly you can unmute yourself and you can raise some questions. Hope you have understood this session very well. And so at the end of this session, I hope you have understood what you mean by clustering and what are the different methods of clustering in brief, and the implementation of K-means clustering algorithm. And you can have a flowchart of this one also if you want. Or tomorrow I'm going to come up with a flowchart of this one so that you can write some program for the K-means clustering either in the Python or in C programming. Thank you. Hello? Hello?
Praveen sir.
Sir, sir.
అయిపోయిందా ఓకేనా
అయిపోయింది. I'm asking whether any students have any sort of doubt.
Okay. Students, by today evening we will schedule the complete lecture schedule for the next week and communicate by end of today.
Yeah, dear students, any doubts? Kindly please be, if you hesitate to ask something orally, kindly you can write in the chat box also so that I'll come up with the solutions for your questions. Okay, if you have any sort of doubts, please. Vamshi. Mr. Vamshi Krishna Gupta, are you there?
Yes, sir.
Yeah. Are you able to understand?
Yes, sir.
Please, kindly let me know if you have any. Mokshita, are you available?
Regarding PPT, everything will be uploaded to your portal, CMS login. You can download it from there.
Okay, sir.
Yeah, sir has given a very good point. The input has given that this entire PPT slides will be given to you and the recorded video will be uploaded to your CMS login also. Okay, so thank you very much. There is another session which is going to start. Thank you for your kind cooperation. Thank you.